Good afternoon, EC 373. We're group number 31. My name's Edgar,
Alejandro.
and this is our game. It's called Almost There, and this is pretty much the highlight of the code itself. It's going to be introduced by Alejandro at first.
So the first class is the game loader. It's a public interface. This was mainly implemented because first the game was failing because everything was in one thread, so we had to program the game in multi-threading. So basically all the visual images are getting processed by one thread, and all the game engine, it's in another thread. So therefore, like, we update everything and then we just paint it in the visual images thread. The other thing is because of abstraction, it just makes sense to have like the runnable or whatever runs the game in a single class and just connect that to like the game engine and the GUI. So basically all swing components like JButtons and action listeners are within a thread called event dispatch thread. So basically we just create that, we just call that thread, and we basically create the GUI within that thread, because everything and all the components are within the JFrame, which is this class. We basically use invoke later because we want to do it asynchronously, because we want to update all the values within our code and then paint them. So everything gets processed for the game engine, and then we just call a function called default toolkit sync, which actually updates the information in both memories. So that's it, and then we go to the game engine. So when you set default, this is the default constructor, set all these values. This is the proto image, you load it here. So this is where it runs the cinematic. So it basically creates, if the timer is not set to true, which it should not be, it basically creates a timer which call a function that creates a certain times of or certain iterations for that. Like every 96 milliseconds that function gets called, and then it basically call this function back. But because we set once equal to true, this is not going to happen again. So we basically change the background a lot of times, 165 every 96 milliseconds. So if I created a JavaScript that takes the captures from the computer every 100 milliseconds. So we can actually have images for the game, and basically they all have the same name. So you just have to change that iterations within that function.
And just to echo a little more about what Alejandro is saying here, as you can see, this is a .jpeg files. One of the dilemmas we had was coordinating or synchronizing in parallel with the audio, and just a lot of trial and error there. But that's pretty much what we ended up with, 96 milliseconds for every 165 frames.
So you basically go to the game and init game. You load the images. So in init game you get where the player should start within that map level. So every map level, if it knows the level that it is, you should get the location for that level, where you should start, where you should end, where the enemies should be. That's basically another class. If this sets the music depending on the level, so we just repeat the song for level 2 and repeat the song for level 6. Everything else should be changing. So if the timer is not equal to true, which is, if you didn't saw the cinematic, or if you see it actually, we change it, because the game initially was programmed with a different delay. So because I don't want to take out the performance, I basically did this. So in load the images, it doesn't only load the images, it actually loads the background and that kind of things, but it actually also creates the list of enemies, because every enemy is one class type, and we create each of them depending on the level based on the difficulty. So if the difficulty is easy, it's 0.66, if it's normal it's 1, and if it's hard it's 1.6. so this should increase the enemy frequency, which is part of that, because if you see this for loop, the map level determines to get enemy frequency, so this will increase the number of enemies based on that level.
So just to talk a little bit about the collision detection system or part for the program. It's pretty much dependent on the map level. One of the features we did put is on our main character, and it shows on our first level that we'll be showing whether the collision from the vehicle or the bus is from the left or the right. That would decipher which way our main character would collapse. That's also not to mention our sound that we put. Again, that's something that we'll be showing here in a little bit. But as far as the collision detection, that's pretty much the general idea of it.
So because the timer is updating so fast, we have to add like iterations. So the visual image doesn't get like updated unto 3 iterations of the timer, or like 300 milliseconds, because it's easy to see like a change if there's some delay to it, because 100 milliseconds is way too fast for our eyes sometimes. So it just makes sense to have a timer for that. And then we set collision equal to true, so it actually delays how much you look at things. If you actually update things too fast, you will never be able to see any change in some things. So for the images, every image is kind of like a square, and they have a white background. So if it wasn't for this filter, you will see like the image of a guy and then like a white covering the background. But because we did this filter, it just basically makes the white transparent to the background, so every image can looks like part of the background.
Pretty much the way we ended up doing the images for this was on Paint. Just use the eraser or white line and just tracing out the character image or the enemy and so on.
So this function is what updates the player. Basically, if the player loads the image depending on the level, because each level has a different image for the player. So it updates the player depending if it's a collision, right? And basically the movement of the player is just like a state machine. So if you're stopping your state 0, which is this state, if you moves one leg, it moves the other leg, different states. It's basically a state machine for the movement of the legs. This is for the enemies. Basically, you do the same, but it's a little more easy because you do not set two states for the enemy, because they will never stop, kind of like you. So it's a state machine with 2 states. Just basically change that. And then every time you update an image, you have to call the filter, so it actually whites that image up. And the erasure go. So this is the key adapter. This is basically what it actually senses the key press that you do. So you can play with the left or with the letter A to go to the left, and this is the God mode logic. So to move, if you collide it, we don't want you to move. So this is the tag map conflicts, knows the boundaries for each map, and it knows if there's something solid within the map, because you know that you should not be trespassing some things because the image will make it. So some math, using some slopes, some simple math, and you get this equations that define the map. So this checks the end of the map. If you cross that map depending on the level, you basically finish the game and go to the next level. So here starts the enemy. So in order to make the game a little bit harder, the actual enemies start a little bit behind the scenes where you cannot see them. So you basically move them by a random integer, so they will appear random to the user, because you don't see where they appear, and if you just appear them always at the same spot, they will look like they have a pattern. Therefore, I just opted for this random integer. Every time they appear, they just move to the left or the right, depending on what part of the screen is it. So here's where the enemies moves. So basically, they set the velocity. If they start at the right, this should be negative. If they start at the left, this should be positive. The velocity. This is set when the enemies get started. So this is where the enemies disappear. If they actually know where they should be disappearing. So if they're within the range, they should disappear. This else statement was added because if in case this function didn't work and they're insanely out of bounds, they should be disappearing. So this paint component, so basically this is like a super class of JPanel, which is part of this class. So we basically call the do drawings and then draw image. This is the background. If you're in game, if you're in the menu, if you're in difficulty, you basically paint all these functions. This is what I was talking before about the asynchronous memory. So basically this basically makes the main thread memory and the graphical part memory synchronized. So here you draw transparent images. So this is what the timer calls every time you happens. So if you're in game, we want to check the end, enemy move, enemy disappear, if there's a collision detection. This is the number of iterations that we want to stop if there's a player change, and this is the player state, default player state. So basically this repaints everything and everything continues to. So this is start menu, you create the buttons, you load the images, you set them where they should be. And this is the button action listener. This is handles the start. This sets if you want to see the image. This basically runs the cinematic. And this is in case you're playing hard. It just starts the game right. This is a load game because it was really easy. Just basically get the level. Just because of the way it was implemented map level. If you use the default constructor, it would not work, but if you set the level in the constructor, it will get everything perfect. And this is the game music, which is a public, it's a static method because it can be used in any class because it's really useful.
Good afternoon, EC373. This is group 31. It's composed of me, Edgar, and
Alejandro.
And this is our game named Almost There. Pretty much the highlight of it is as we were brainstorming, we wanted to come up with something that everyone's affiliated with, and what better place to make it here at the U of A. And obviously, as you can see, our main characters would be Morty and Rick from the Rick and Morty show. And well, this is our main screen, pretty straightforward. Buttons play, load, settings, and pretty much underneath the settings is just pretty much the difficulty, easy and hard, and pretty much our load button.
And the song is from World of Warcraft Wrath of the Lich.
So on to our introductory video.
Everybody off.
That
Morty,
was
I need your
bleeped
help.
out, so we should be A-okay
We need to go
about
on a
that.
quick adventure.
You said I could go to school today.
That was before I needed something, Morty. There's a plasma shard in the Abadongo cluster. A princess has it. If I get it, I'll be awesome.
We've been going non-stop, Rick. It's not healthy. You know, these are my teenage years. I just found out Jessica's single.
Oh, that's wow, Morty. Wow, what an exciting life you lead. Let's go, in and out.
So yeah, the
Adventure.
video is a little contradicting, but we thought it was just ideal for the wormhole portal. Obviously, like I was mentioning earlier, we were brainstorming and we were thinking about games affiliated with everyone that everyone's aware of, and we decided to go with the Frogger. That what you just heard was obviously Homer Simpson, and pretty much these brown cars are our 87 Chevy Caprice. That's pretty much what we thought it looked like. Now the background, we wanted to go with something like three-dimensional. Obviously, we wouldn't be able to do that, so we tried to mimic that. And one of the ideas Alejandro had come up with was that of like Paper Mario, where we make the background actually 3D, and then the playing field where we see the road as a two-dimensional.
That gives you the depth perception.
Yes, that would give the depth perception, kind of just optical. We would call it, yeah, optical illusion. And then we just crossed 6th Street onto our football stadium. Those right there are real U of A football players. Now, obviously by their side, we just can't see their the Arizona logo, but it's there. And pretty much again, decided to go with the same with the same idea of the 3D background, 2D playing field. Pretty much the background was obtained by Google Maps. Went with the bird's eye view, just cut off the image using paint, and then just laid up on top. From here on level 3, we had multiple ideas originally for our enemies. That being like a wildcat, the T-Rex from Google, which I would have thought would have been awesome. But at the end, we just decided to go with the characters, the students. And one of the things you may notice is Morty leaning sideways, diagonal. With the first level, he's facing your back. Second level, he's sideways. In this case, he's diagonal, considering the students are running in a diagonal direction as well. So, and then on to our fourth and final level. This level here is known as the Devil's Avenue, and we all see why. It's as difficult as it gets. But up front, as you can see, we got the Harville building, and onto our class. As you can tell, and as mentioned during the code, the collision detection, as Morty is collided from the left, he'll be dropped over to the right, collapsing to the right, and then restarts to the normal course. So one of the things we have to talk about and to introduce right now will be our God mode cheat that was composed by Alejandro, and this is pretty much, we just got fed up by Alejandro just souped it up and created the God mode and just blast right through the avenues. And obviously here are our credits. Main character, mentioned Morty. Location, U of A, of course. Audio engineer, Alejandro. Fashion designer, sign up. Food displacement engineer, me. Google Doc, sign up. Collision detection producer, character coordinator. Custodial engineer, did some cleaning. Makeup artist. You know him. Stuntman. U of A football players, Justin Bieber. And we gotta give some credit to our friend Javier Figueroa. And then conditional programmer.
It had to be in the game.
Conditional programmer Alejandro, and some of the things, concept developers, all of the above, and some of the things, mathematical developer, TI-83.
Spell checker.
Yes, me as the spell checker. And just a special thanks to Dr. Rambat, Google, Stack Overflow, Monster Energy Drinks, of course, Circle K across the street, made multiple runs out there, Wikipedia, and obviously the Rick and Morty Show. And that's pretty much it. Hope you enjoyed.